Okay, second method is method of variation of parameter VP. Okay, method VP has a distinct advantage over the method UC, undetermined coefficient. Okay, that it will always yield a particular solution YP, provided the related homogeneous equation can be solved. Also, VP, unlike UC, is applicable to DE with variable coefficient, function other than exponential, trigonometric and algebraic. Okay, now look at the summary of method of VP. Okay, consider a second order non-homogeneous ODE. Okay, A2 y double prime plus A1 y prime plus A0 y equal to fx. Okay, then divide through this equation by the leading coefficient to put the DE in the standard form. Okay, next we find YC. Compute the Wronskian. Okay, for step 4, U1 prime. Okay, find U2 prime. Next, find U1 and U2 by integrate for step 4. Okay, and then step 6, we find YP. Okay, YP equal to U1 Y1 plus U2 Y2. Okay, next, general solution Y equal to YC plus YP. Okay, now we look at example 17. 1 Roman. Okay, we have y double prime minus 4y prime plus 4y equal to x plus 1 time with exponent 2x. Okay, first we need solve for YC. So YC, solve for homogeneous. Okay, so we have m equal to 2. Okay, case 3, real and equal roots. So YC equal to C1 exponent power of 2x plus C2x exponent power of 2x. Okay, next we solve for YP. Okay, we use Wronskian. Okay, W exponent 2x, x exponent 2x. Okay, we take this one. Okay, so substitute exponent 2x, x exponent 2x. Next, we differentiate. So this one we need to use product rule. Okay, so find the determinant for this one. AD minus BC. Okay, so we get exponent for x. Next, we find W1. Refer formula W1. Okay, 0, y2, fx, and then this one is y prime 2. Differentiate y2. Okay, find the determinant AD minus BC. So we get this one. Simplify. We get negative x plus 1 x exponent for x. Okay, next. W2, refer formula W2. Okay, we have y1, 0. Okay, y1 prime, differentiate this one. Okay, and then this one is fx. So, find the determinant y1 fx. So, we get this one. Okay. Next is find u1 prime. Okay, so u1 prime, the formula is w1 over w. So simplify, we get negative x plus 1. Okay, so we find u by integrate u prime 1, u1 prime. Okay, so integrate, and then this one is answer. U2 prime equal to, okay, the formula is W2 over W. X the answer is x plus 1 after you simplify. Okay, next we integrate u2 prime. Okay, so we get x square over 2 plus x. Yp equal to u1. Okay, so take u1. Okay, y1 plus y2. Sorry, u2 y2. u2 y2. Okay, then we get yp. So y equal to yc plus yp. Next example is 2 Roman. So y double prime plus y equal to secant x. Okay, so we need to solve for yc. Okay, we get positive, negative, I. This one is complex number, right? So, case number 3. Complex conjugate roots. The answer for yc is c1 cos x plus c2 sin x. Solve for yp. Okay, this one is y1. This one is y2. So, w, y1, y2. Okay, substitute y1, y2. Differentiate y1, differentiate y2. Okay, next we find for determinant. Okay, AD minus BC. So, we get 1. Next, we find W1. Okay, the formula for W1, 0, fx. Okay, fx, this one fx. Okay, and then y2, y prime, y2 prime. Okay, differentiate sin x, we get cos x. So, the answer is AD minus BC. Okay, so we get negative secant x sin x. Okay, so we simplify, we get negative tangent x. W2. Okay, this one is y1. Okay, and then differentiate y1. 0 fx. AD minus BC. So, we get 1. Okay, next find u1 prime. Okay, this one, the formula is w1 over w. Okay, then we get negative tangent x. So, find u1, differentiate u1 prime, then we get ln cos x. Okay, next, u2 prime, the formula is the formula is w2 over w. Okay, next, find u2 by integrate u2 prime. So, we get x. Yp, u1, y1 plus u2, y2. So, substitute. Okay, and then find y equal to yc plus yp. So, yc plus yp. That's the answer. Next, please do it for number 3, 4 and 5 Romans.